presentation, and then we will see a live demo with the main features. Okay, so since we are a small group, feel free to stop me at any time if you want me to explain any specific feature. All right. But well, just as an introduction, Lens Design is a software that we develop at SUNY in Barcelona. We belong to the same group as McNeil Europe. All right, so we are very in a close relationship with all developers of Rhino. And Lens Design is also available for AutoCAD. So we develop the program both for AutoCAD and Rhino, and has almost exactly the same features. Okay, so Lens Design, it's a BIM software for landscape design. Okay, that it integrates tools for generating 2D drawings, of course, the 3D modeling, and some documentation tools for listing, okay, all the data of elements that exist in the model. And we will see also some animation tools. Okay, so basically it's aimed at well, landscape architects, but also people that work in a green infrastructure, urban planning, or environmental projects for forestry, for example. Okay, so why to choose Lens Design? First of all, it includes an extensive plant database, okay, with many different plant species that include the 3D representation and also 2D crown for well, displaying purposes. Okay, so from this plant database, as we will see later on, you can search for one specific plant species according to different filters, and then insert it in the model and have it ready to render or to show it in plan view. Okay, we'll see that later more in detail. So basically, these plants have different representations. So conceptual, animation, detailed, or realistic. And this realistic can be fully customized, okay, with this plant editor that you see here. And they can handle different representations by seasons. That means that we can do some season change simulation just by well, selecting the season in which you're going to render the scene. So here you see an image of the scene project using the different representation modes of the plants. Okay, just with one click, you can switch from one representation mode to another, or show the entire project in 2D. Okay, we'll see that later on in the live demo. So also, Lens Design includes a set of tools for terrain modeling. Okay, so basically you can create terrains from curves, point clouds, okay, or a combination of them. And then you can work with the topography as adding cuts and fills, okay, or adding paths on the terrain that can be easily edited just by pulling control points of the same curve used for generating the path, okay. Or also you can add divisions to the terrain to assign, well, different materials, all right, and have this information later on in lists. So this is another way by which you can import terrains, generate terrains, in this case, from the web. So there is a tool that lets you navigate over the world, go to a specific location, and scan the area that you want to import to generate a textured mesh, okay, or Lens Design terrain. So in this case, I'm selecting here an area next to Barcelona, okay. And what you can see here is a terrain generated already for that area. So there is all this elevation data that is used to generate a terrain. And here I am repeating the command, but in this case, I'm generating a textured mesh, okay, with the same area. So that's useful to have a reference of the roads, all the vegetation masses, or volumes for buildings that we have in this area. Well, also Lens Design provides a set of documentation tools. Okay, for example, as I mentioned, you can list all the information of elements. So we can have a plant list or a urban furniture list, or also add pictures of the plant species that we are using in the model. Also tools for dimensioning, and at the end of the day, have all the plant sections and documentation of the project. Also, it provides some irrigation tools to insert sprinklers individually or arranged in an arrayway, or define some lines as the piping system. Okay, so basically they are curves with some information that you can later on list for having the pressure, the diameter of these pipes, and so on. Also, I would like to ask you, maybe you can write it in the chat, or maybe let me know if you know Grasshopper. Okay. Actually, I would like to know if you are already familiar with Rhino or not, so I can focus, the presentation more. While considering that you are familiar with Rhino, otherwise I should explain more in detail everything. But for those that you don't know Grasshopper, well, it's a plugin for Rhino that lets you automate processes, okay, through components, and all the tools to generate plans, terrains, paths, and other commands for lands are also available in Grasshopper. So this lets you automate also modeling workflows and modeling tasks, also using lands components. I'm going to show you an example here. Later on, I will show you another one. But basically, here I've got a definition where I pick a boundary curve and just another curve to generate a forest, okay, a population of plants that will take the boundary as a contour and this curve as a path. And the idea is that all the plants take their height according to the distance to that path. Okay, so this is a totally parametric design. And with this definition, I can control the number of trees, the range of variation from the smaller to the highest tree, okay, the path width, and so on. So you have control parametrically of all the features of this definition. Well, you've got here some other commands for land design to generate hardscape. Okay, there are wall tools, fences, paths, stairs, and also a library of furniture blocks. Okay, we'll see that later. And finally, there are some tools to produce animations and virtual tours. Okay, the idea is that all these visualization tools let you navigate through the project in a walk mode. Okay, activate sand, produce, cast shadows. Okay, and produce renders easily from the project. So this short video explains a little bit the design process with Lines Design. Just as a summary, for example, we may start by scanning an area, okay, where we are going to work, and or we can start also with some control curves. There is a tool that elevates all these curves according to an interval, and from those curves we can generate the terrain. Okay, once we've got the terrain, just pulling all the control points, we can modify it, and later on we can zonify. So we can define the areas at like labels for these areas. So later on we can quantify them. Okay, and finally we can insert all the vegetation species. So we can search for one specific plant species, and we can insert them individually or also arranged in rows, as you can see here, in rows that are completely parametric. So we can define the number of units, the separation among these units. We can arrange also plants in forest, as we can see here. Okay, and we have full control of the number of units and all the parameters. So we may continue by inserting blocks. Okay, for example, in this case, some benches or street lamps. There is a library of blocks we will see later on. And here we also insert some playground stuff. And all these elements have a 2D representation as well. So at the end of the day, when the project is done, we can switch from 3D to 2D at any time to present the project also in a plan view representation. Okay. Also, we can work from this 2D view. So anytime you can switch from 3D to 2D, depending on how you want to work. But finally, when it comes to document this, we have these tools to show a list of plants, urban furniture blocks, terrain modeling, volume of land movement, and tools to do some animations or this 360 degrees view. Okay. And this scheme shows a little bit, the workflow of using Lines Design. Either if you use, if you produce, for example, 2D technical drawings from directly in Rhino, or you have them already in DWG created in AutoCAD. The idea is that you put all these drawings into a Rhino environment with Lines Design, you start modeling stuff on top of these 2D drawings, or you can generate the terrains, as we have seen, by importing them from the web or importing GIS data, okay, that maybe may have, the point cloud of the terrain elevation data, or the position of roads, plants, etc. So after we end up with a project, we can send it to visualization. So in this case, you've got all the render engines available in Rhino. Can be used for land designs to render the scene. You don't need to do any translation of materials. So all the land design elements can read materials from V-Ray, Flamingo, and so on. Or you can connect the model to render viewers, okay, like Enscape, Lumion, Twinmotion. There are some issues with some of them because, well, they have different ways of managing blocks and Rhino geometry. And, but well, we are in close collaboration with them to solve all these issues. So this is something we could say that is a little bit under development, but still you can already create good results, okay? So, well, you can not only collaborate with all these viewers software, but also with other programs. Since from Rhino, you can export the model with many different formats that are available for SketchUp, Revit, okay, or other ones. So finally, you can export all the data that is generated with Lens Design to Excel, to PDF, all right, or generate the drawings for printing. So, well, this is the website and support. Now I'm gonna show what I have described here, but in a live demo, okay, which I'm sure it will be more, way more interesting for you. Well, maybe if you have any questions right now, or if you would like to know if you already know Rhino or Grasshopper at least, maybe you can put it in the chat box or talk, I don't know. It would be very interesting for me to know. Okay. All right. So if nobody says anything, I will just go on. Okay. But again, feel free to stop me if you have any questions. Okay. And I can focus more in detail on one specific feature, okay, or well, detail that you want to know more. All right. So you can see here a small garden, okay, generated with land design tools. But also in this model, I've got here a Rhino surface. So, well, you can combine everything in the same model, okay? Rhino geometry and land design elements that you can find here in the toolbar. So I'm gonna show a little bit the main toolbar with the main commands. There is one toolbar that includes all the commands of land design, a long one, but the same commands are available here grouped by topics. So you can find here the commands to insert plants individually or arranged in rows, forests, shrubs, or ground covers. Also, plants can be inserted individually or from points. That means that if you have some points that determine the location of plants, you can just run this command, select all the points, and the plants will be created there. There is also a way to generate plants in a paint mode that we will see later. And well, here you can find also the tools to generate all the civil work like walls, fences, stairs, paths, or rows of elements that you can find in the library. And well, some commands for working with terrains, okay? Generating terrains, again, from points or curves. Then you can, well, define the boundary by a closed curve, add new data, new contour, or add holes, cut some fields, paths, or make divisions, okay? So any of these operations will generate some difference of land movement that can be quantified with this command. And here you have the command to import the terrain from the web, okay? Or elevate curves that are planar and according to an interval that, and later on you can create a terrain from them. Well, here you have some other tools for documentation. You've got this sprinkler or pipe command to do the irrigation system. Here you've got all the tools for listing the different element types of land design, tools to tag plans, okay, to insert plan photos, labels, dimensions, slopes, zones, plan shadows, okay. And finally, here you've got, well, the tool that opens this edit panel that I have already opened, which is maybe the most important dialogue in land design, because from this dialogue, we will be able to edit the elements that we select, okay. We've got here also the animation panel that I'm gonna open now, that we will use to generate some animations. This is a shortcut to the plan database that we'll see later. This is a command that opens a filter application just for selecting images, applying filters, and saving them. It's kind of a light version of Photoshop included in land design. And some other commands to set different viewpoints, or put you in a walk mode to walk through the project interactively. Okay. But let's take a look at the edit panel, because when nothing is selected, actually I'm gonna put this toolbar up here. All right, so we have more clear space in the interface. So taking a look at the edit panel, we can see here in this part a list of the different species. Okay, so we can select them from here. Okay, we can select the different species, and as you notice, we have here the different representation modes. So we can change that clicking this button, and this will affect to that document. Okay, I'm not showing this now because I will show you later how to do it in the plan database that will affect to other documents. Okay, or when you start a new document. But from here you can select all the different species that you've got in the model. When nothing is selected, what you see is the document properties. So here you can switch to different representation modes of the plant's elements. Okay, for example, we can switch to these elevations. All right, or use the conceptual display mode. Actually, I'm gonna turn off the sun. Maybe it's more dark, but I will work a little bit faster. So you have the conceptual, the detailed, okay, and finally the realistic. So there are different representation modes that each plant has, and depending on how you want to represent the project, you show one or another. And actually, this realistic representation mode has two different ways of showing them. One is the 3D, and the other is this billboard. So when you choose this option, what we see here is basically a textured surface that orients towards the camera. And this is especially useful if you want to still see, you know, all this realistic representation in rendered mode when you have a large amount of plants. Okay, since this is just a surface, you can handle a large number of plants and you will still work fast. Okay. But since this is a small project, I'm gonna keep the 3D representation. And also here, if we scroll down a little bit, we can see the season of the current document. This will determine the appearance of the plants when we shot a render. And also, it may change the appearance of the preview of these plants in the viewport, because some plants, what you see here is basically a simplified representation of the plant when you render it. So when you render, you get a more detailed plant that you see here. And actually, if we switch to winter, for example, some of these plants use a different preview also to let you know that they have a different representation according to the season. All right. So as you can see, the jacaranda changed the color of the leaves, and this Acer platanarius also only shows the skeleton. Okay. I'm gonna switch this back to spring. All right. So besides these, well, these different representation modes, Okay, you can also switch from 3D to 2D, as I was explaining before, by clicking any of these buttons. When I click this 2D button, all the plans, all the lands elements switch to this 2D representation. So when you're working from the top viewport, you can have the feeling that you are working in 2D, all right? You can insert plans, define all the boundaries of the project, okay, work with terrains and so on. And at the end of the day, just click here to switch to a 3D representation, all right, and see how the project looks like in 3D, okay, with all the textures on the materials, on the elements ready to be rendered. All right, so before we talk a little bit more about the vegetation, I would like to show one of these documentation tools, specifically the zonify command, because this is one of the first steps in the design process to define the areas of the project and well, have a label and an idea of the amount of area. So with this command, basically you select one point inside one area. Okay, this reads the boundary. You can also select a boundary curve if you want, but basically here I would just give a name like playground. I need to define also head of this text, and also I can define a hatch pattern when I show that zone object in 2D. So I'm gonna select maybe a different hatch pattern, and also a material in 3D. Okay, so well, this is the material that comes by default, but I can browse in well, the library of materials that are available with Lens Design. Okay, then well, that well, you can use for the texture of the zone. Okay, so I just need to insert now the label, and you see here the texture. If I switch now to 2D, I will see this hatch pattern, okay, as a 2D representation of the zone. And of course, you can select it afterwards, and from the edit panel, you can edit it. Okay, we can change the text, we can change the material if you want. If you have already a material that, for example, you have a library of materials, if you use V-Ray or another render engine in Rhino, you can also select it from here. Okay, you can select any of the materials that are loaded in this document. All right, so any object of Lens Design can be edited afterwards from this edit panel. And from this part of the edit panel, you can have also some actions to, for example, copy properties from another curve. See if I want this zone to be like this one. Okay, we can copy the text, the texture, the material, and so on. I'm gonna do this by now. All right, let's insert the plant now, so we can see a little bit the plant database, how it works. I'm gonna delete this plant, and just well, I will just run the plant command that shows me a list of the plant species that I have already used. So in an empty document, this will be empty, of course. But so the first thing I would need to do is to browse in the plant database for a new species. All right, so here we can navigate over this list that shows me the species that match with the filters. So I can click here for fragrant plants with suitable for screen. All right, and just click on all these filters until I find the desired species. I'm gonna clear this now. But also you can, well, there are different groups. So I can show favorite ones. So if I mark any plant with this heart icon, it will be added to a favorites list. And I've got some plants that in this with render group, that means that they have a specific realistic representation assigned for that plant. Because there are over 2,000 species in the plant database, but not all of them have a specific realistic representation. So some of them, we will be able to see this if we select the list all. So some of them, they just have, for example, when you see this in gray color, that means that this species doesn't have a realistic representation, but it uses the most similar one. Okay. But anyway, we can find here desired tree, for example, a lemon tree. All right. So I'm gonna select this one, and I'm gonna also use these cloud images to import, images from this species from the web, and I can check the properties of this plant, so you can see which features you can edit to it. So I will click on this button to change any detail I want. All right, I'm not going to touch anything of this, but specifically for this display representation, it could be interesting to say, okay, I would like to change the 2D crown for this plant. So I'm gonna browse for the folder where all the 2D crowns are available. Okay, there are a bunch of them. I can select, I don't know, well, this one, for example, and this change will be applied on the plant database. So next time I open a new document, I will have the lemon tree with this 2D crown. And you can do the same with the 3D representation, the detailed representation. And here under the render tab, we can assign a realistic plant species to that lemon tree. So this realistic representation uses an AR3 file format, which is a file format that can handle different representations, all right, and integrates all the textures in the geometry. Okay, and actually we can browse the plant editor to modify any of these files, okay, or start a new file from scratch that later on we can use for a new species. Okay, excuse me, I forgot this in Spanish, but maybe just playing with these values, you will get a picture of all the potential of working with this application. Okay. Well, here you just play with these sliders until you find the desired appearance. Okay, and you have here some other parameters for the trunk. Okay, the number of branches, etc., or the material, the texture that is assigned to that part of the geometry. Same for the leaves, for the fruits. Okay, and as you can see here, there are already 4 definitions assigned to the tree, and each one is each different one is assigned to some season. This is spring, end of spring, and you can see how it changes when we switch these definitions. So you can add a new one and save it as a new representation for one specific season. Also with this editor, you can create a new representation, plant representation types from different templates. So for example, this is a conifer template to start modeling a new plant with this shape. Okay. Anyway, I'm gonna close this by now. I'm gonna cancel this. And well, you can copy any of this existing species to work on the copy and create a new species, or you can start from scratch, from an empty sheet. And here you have an empty sheet that you can fill with all the 2D crown, 3D blocks, okay, for the different representation of the plant species. So you can actually build your own plant database if you find some missing species. All right, so I'm gonna select the lemon tree. And well, in this insert dialog, you can define the approximate height. And also you can enable this natural variation. So if you insert multiple plants, all of them will get a slightly different difference of height. And also it's important to check this random rotation so they also rotate a little bit one to another. And well, I just finally need to insert it in the model. Okay. And once it's done, this is done, I can select the plant. And here from the document, from the edit panel, I can change the species, I can change the height, all right, and any of other parameters. Do you have any questions so far? Just unmute yourself or use the chat box if you have any questions. All right. If you don't, I will just go on. And okay, I will talk now a little bit about the terrain modeling tools. Later on, I will show another example of creating forests, okay, or ground covers. But now I would like to explain a little bit some of the tools to generate terrains because they are very close to the way plants are inserted. So in this case, I've got a random surface, and well, there are two different ways to create terrains in land design. One is by tagging a surface as a terrain. So I can select this object, and here in the edit panel, I can select this tag as terrain option. So when you do this, all the plants that are located within the boundaries of this surface will be projected on top of the terrain, as you have noticed here. That means that now if I copy, for example, this plant over the area, the plant will detect the position of the terrain and will be automatically located on top of it. Okay, but the drawback is that this surface doesn't have all the features, all the commands available for a true land terrain. So with a very few steps, we can convert this surface into a land design terrain. So I'm going to use the contour command. So it's just a Rhino tool to generate some cross sections on this surface. Okay, so I will pick this point to generate the cross sections. So I will generate contours every 2 meters. And now I'm gonna put this in this auxiliary lines layer, change object layer, so I can contour them on and off. Okay, and now I can already get rid of the surface. And now when I create a terrain, I will select these curves, so we'll generate a terrain with a similar topography as that surface. So now I can run the terrain command. There are two methods to generate the terrain. One is by straightforward Delaunay triangulation, and the other one generates a gridded surface shaped to triangulation. So we have control over the size of this cell, of this gridded surface, which gives us more control of the level of detail according to the initial data. Okay. So I'm gonna select these options, these default options, and now I can select the curves, except this one that I will use later on for adding a path. And when I hit enter, the terrain will be generated. Okay, I can actually hide the auxiliary lines and check this terrain out. So as you can see here, we've got the same control curves, okay, the same control points as the curves used to generate the terrain. So I can work with, I can pull these control points, okay, to modify the shape of the terrain as I wish. Okay, but since I don't want to see all these control points every time I select the terrain, when well, there is an option when you select the terrain in the edit panel under the input data that enables you to turn them off. Okay, so when you turn them, you won't see the terrain control points every time you select it. But by the way, when you select the terrain, you see here all the features, okay, of the terrain object. So we have full control how you want to display, for example, the contour curves. When we see the terrain in 2D, we see all these contour lines. I'm gonna move into 2D now. And rather than having a 10 number of contours, which doesn't make much sense, I'm gonna define the distance. Okay, I'm gonna set this to, for example, to 20 centimeters. Okay. And actually here there is an interesting option. So you can enable this index contour. So you will have every certain number of contours aligned with a different, line type or color. Okay, so it will give better feedback of the contours. Actually, you can see these labeling names are very big. So I'm gonna change the text size to slower value. Okay, so you have full control of all the features of these contour curves. All right, so I'm gonna put this back to 3D. And from the viewport, I'm gonna insert a path. Okay, so we'll use this curve that I already have in the 3D model space. Okay, and this command, I mean the command to add a path into a terrain, will will change the topography of the terrain so it fits with the position of that curve. Okay, so let's do it. I run the path command. I select this terrain. I need to define here a width, let's say 2 meters. Also an angle along the path, okay, how the terrain will meet the boundary of this path along its axis. And finally, I need to select a curve, a path curve. So you can see here the curve. The path has been added to the terrain, okay. And now when we select it, we can see that we've got here the terrain control points. Okay, so we can select these points, so we can change the position of this path in the terrain. Okay. All right. So also when you create this operation, adding a path, or also if you add a cut and fill or division or a hole, you can also assign a different material to that part of the terrain. So in this case, when we have selected this terrain, we can select this subdivision from here, and then we can assign a different texture. We can browse in the library of materials and select, for example, a kind of grass. All right. Okay. So all the data that we are working on this terrain is stored in the object. So we can go to the input data and now select the path, change the cut and fill angle, change the path width. All right, just delete it if you want. And so you can go back and forth with these operations at any time. Okay. And actually you will also get all the information of the Earth movement. Okay, so if we go to the listing tools and we insert a terrain list, we'll get now the data of this, of the amount of volume, okay, that has been added or subtracted after doing this operation that of adding a path on this terrain, okay. And it's completely dynamic. If we change the topography of this path, position, or the terrain, these values will be updated. Any questions about terrain? I see you are all muted, but feel free to use the chat box to ask any question, okay, or unmute yourself. It's up to you. Otherwise, I will just go on. So I was saying that I would like to show you some more example of how to insert elements, vegetation elements in the scene. For example, we can insert a forest. in that project, I'm gonna select any of these existing plants, for example, this Acer Platanoides. And well, here you have the features of the plant. And under the forest tab, we define the number of units. So I'm gonna say 30 units, okay? The minimum distance among units, or if we want to generate the forest as an array. Well, when we click OK, we can either select a boundary curve. We could create a forest inside that area, or you can just draw it in the scene by using any of these options in the command line. So I'm going to select the polyline. I will disable the snaps. Okay, so you can just draw the boundary of the forest this way. You don't need to close this. I mean, when you do right click, the plants will be automatically projected. Close it, I mean. But if we take a look at the 3D view, you can see that the plants have already projected on top of the terrain. This way of inserting the forest was totally random. I mean, puts a random distribution of these plants. If you don't like this distribution, you can go here to the edit panel, forest, and redistribute. It will always detect the topography of the terrain, so the plants will be always projected on top of it. And well, here you can change the features of the forest. Let's say we want to 40 units, or we can check the this array way to insert them. For example, to insert plants every 5 meters. Also, we have enabled this natural variation, but if we check it off, all the plants will have exactly the same height. Okay, but which is not what I want. Another interesting feature of available in forest, but also in rows. For example, here we have already a row of plants. Is that you can combine species. So, for example, I'm selecting back this forest, and we can say that we want 2 elements. Okay. So when you do this, we've got these 2 different species from this list. And by selecting one or another, okay, you can change the species in that forest. Okay, so we can change this species, change the height, okay, and have a forest that combines two species. All right, let's take a look at the ground cover. So I want to mention this command because it generates also vegetation elements that are using a different NXT plant file, basically the realistic plant file. So it distributes the 3D shape over an area. So I'm going to browse in the plant database, which are the species that have this kind of representation. All right. So you can select any of them. Also, ground covers are represented with a hatch pattern when we switch to 2D. And actually, you can disable this if you like. And now we can just well, pick an existing curve. Okay. For example, we can draw here a rectangle. So you see the plants are projected on top of this. And later on, we can select them. We can maybe change the height, the scale, or the density. If we're working from the top viewport, let's switch back to 3D. We will be able to to edit the boundary through the control points. Okay, so you can select this control point and just move it to another position. All right, just notice here that the boundary has this wavy contour. Okay, this is just the 2D representation of ground covers. I'm gonna move also this control point a little bit further. So it's up to you if you like to work in 2D or in 3D, but you always get, the result in the 3D view whenever you want. All right. And also the ground cover commands are meant to be used for green walls. Actually, forests and shrubs or even rows can be used this way. But I mean, if you select a curve as a boundary of this ground cover that is located in the vertical position, I'm going to select this species again. I'm going to change the scale right now. And well, no, the scale I've got it here. I can select, for example, here a vertical curve that they have on this wall to have a vertical green wall. Okay, a vertical green wall on top of this wall. Later on, maybe I can change the density of this plant so I have more dense, more dense ground cover on that wall. All right, so well, let's take a quick look at some of the civil work elements. For example, we can insert walls. Okay, just by selecting here a thickness and a height, and also an alignment. So we can pick a curve or draw it in the model on the fly. So we'll click here and just draw the wall. All right, and well, later on you can select it, change. You can also copy properties from another object, so we can make this wall look like exactly like this other one, and so on. But maybe here it's more interesting to see the plan row, the row tool. So it generates a row of elements, for example, that we can borrow from the block library. So we will be able to see the list of elements that come with the lands library. So we have blocks for fountains, for games, people, stones, urban furniture, water games. You have also a list of commercial products catalog that offers different 3D models. So we can insert, for example, a row of street lamps. Okay. So we have here the block selected, but we can also here, well, define the separation of units of 10 meters or maybe 7. Define 1 meter as an offset from the axis and use this curve as we used it before to insert the street lamp row. Okay. So once we have created this row of elements, we can change, for example, the orientation. So we can make them perpendicular to the axis. We can actually invert this so they point to the other side. And we can change, for example, the units separation, let's say 8 meters. Okay. Well, invert the curve so the start becomes the end. So it flips the position in this case, and so on. All right. So let's take a quick look at some of the documentation tools. We have seen already how to insert zones, how to generate lists of terrain movement. We can now insert a list of plants. So I'm going to insert this list here. Actually, I'm going to move to the top viewport and show this in 2D. All right, because this list shows a live connection with the elements we have in the model. So just notice, for example, the number, the amount of units we've got for the Acer Platanores. So this is set to 11. But if we select this option, this first, and we switch to number of units, okay, you see that this value changes because now it has more items for this species. Okay, so when we insert new species, this list updates live. And you can export that to Excel if you want. So there is here a command to export that list. You can edit which information you want to show. For example, we can display the density, for example, that is useful for those species that are used for ground covers. And well, you have different options for customizing the list. Okay. Also, well, you can insert plan photos, as we have seen in the presentation, labels, tags, dimensions. Slope command is also interesting because you can, for example, well, here define a height and also pick a curve. I'm going to select this curve, and you get an idea of the slope, okay, of this path on the terrain. Basically, it measures the start point and the end point on the curve that is projected on top of the terrain and measures the slope. Okay. And well, this plan shadow also drops shadows into the, so it gives more interesting feeling. And finally, I would like to do some small video, okay, small animation of the project. So I'm gonna switch to 3D. Okay, I'm gonna go to perspective. Maybe now it's worth it to enable the sun. And well, from this animation panel, we can define animation name. We can set frames per second or a total duration of it. And here under the camera, we can select a path as the camera path. So I'm going to select this curve. Okay, we can also choose between looking forward or to a specific point. And actually, I can hide this curve now that is already attached to the camera path. And well, here you can choose between the Rhino display or the current renderer engine. So when you shut the animation will be saved according to this display view or to the current renderer. Okay. I can see if we've got a question. Daniel says, my question is about the 2D view of the model. Is it possible to change the 2D view of any object in the model, or there is only one inbuilt 2D pictogram for every 3D object? Yeah, that's correct. So when you switch to this 2D view, the objects are displayed either with a native 2D representation of it, or just basically from the top projection of the model. So that means that if we work with any geometry like a cone, okay, so this cone will be just seen, you know, as a circle from the top when we switch to the representation. Okay, so for the lens elements or the elements from the library, they have already you know, a 2D representation. Okay, same for plants, but for the other elements, okay, or blocks that you can integrate into the block library, the 2D representation will be the projection of the top view. Okay. All right. So I was going to play this animation that I was generating. So we have selected the camera path, okay, and we have defined the total duration of it. You can also play with all these parameters for the camera, or you can enable a season change. Basically, this is a way to change the way the plants will look in the final video from one season to another. And same for the plant growth. We can enable this, so the plants will look small in the start of the animation with the current size at the end of it. And even you can enable a wind, so the plants will bounce a little bit. But these effects are only visible if you choose the Rhino render, which I don't have time to show you now. But they are effects that only are visible that way. But now we can see a preview of this animation for the display. Okay, so you get a look of how the animation will look like in finally. Okay, it gives a good feedback of the animation. Also, would like to show the wall command that I was mentioning earlier. So this basically puts you on the ground, and just with the mouse cursor, you can just navigate through the project. Okay, as if you were in a kind of video game. All right. So it gives a nice idea of how the project will look like, or just for showing it to the client and have a real feeling of how it is going through your design. Well, if you check the lens help, okay, you will see the commands to navigate to the control commands to use this walk mode, okay, because you can use keyboard and also the mouse buttons to change the speed, all right, or you can also go in a flying way, so you are not on the ground but flying through the project. And I would like to end by showing another example of the Grasshopper integration. Okay, just to give you a close, rough idea of the potential of this integration and what you can obtain with the parametric design. So I'm gonna insert here some plants in the paint mode. So I'm gonna select Acer Platanodes and make sure I have a natural aberration, because I want to insert some plants that have different heights. Okay, with display paint mode is cool because wherever I hover the mouse, it will generate these plants. Okay. All right, I'm gonna turn off I'm gonna select these shadows, delete them. So when you now open Grasshopper, I'm gonna close this. I'm gonna select a definition that well uses lens components, in this case to reference plants. I mean, here you can find components to create new plants. So this will be a component that generates a new plant. So it requires a position, a point, okay? And you have here some options to assign a specific species, height, and so on. But the same component is used to deconstruct a reference plant and obtain the position, the options that gives the height of the plant, the diameter, format, and so on. So I'm gonna do right click here to reference all these plants. Auto saving going on, excuse me. So I'm selecting all these plants that are now referenced in this component. And as you can see, these kind of curves pods are generated. Basically, they are circles that take their diameter according to the plant height, okay, and their position. And this is totally automated from here with all this definition. Here I can change the pod thickness, okay, or I can change the height of these borders. And well, you can see here the different components. And since I've got this geometry generated by the position of the plants and the height of it, if I change the height of one plant, okay, you will see that these pods update. Or if I select this plant and change its position, okay, you will see that this pod just update with a new position. So of course, this is something that you can do manually, but just by doing it with Grasshopper, you have all the variations, all the design possibilities very quickly. Okay. Well, before we go to some other questions you may have, if you want to check out in the website the projects created with Lines Design, so you have an idea of the quality of project or how people are using it, just invite you to take a look. All right. And of course, under support, you will find the email to contact us for any specific request. And well, maybe we have time for some questions if you have any.
Igen, én is bátorítok mindenkit, hogyha van kérdés, akkor tegye föl, akár úgy, hogy a mikrofonon keresztül, vagy pedig ide a chat ablakba beírja. Francis, maybe could you tell a few words about the AutoCAD version of the lens design software?
Yes. Yeah, lens design also works for AutoCAD, and well, all the features are the same except, of course, the Grasshopper integration. Okay. So yeah, all the tools to generate plans, to insert lists are basically the same. Also changes the environment. So if you focus your work on 2D drawing, so maybe AutoCAD is more robust, okay, for 2D drawings. But if you are interested to produce a 3D model, then I think right now it's way better, okay, in terms of 3D modeling. So can the program integrate online basis like nurseries actual plant lists? Well, we are working on adding more plant species in the plant database. Okay, so right now, if you want to add a new species, you need to do it manually, you know, by going to the plant database and create a new, let's say, technical sheet of the new species, and collect all the data from any source that you have. All right, but we're going to expand this soon. So we will collect information, we'll gather information from different plant databases that we're finding out there. And also we are working on more 3D representations, okay? So NXT plant files that are generated with this plant editor. There is actually a new version of this plant editor than the one I have shown you that gives a more accurate, more detailed results. So yeah, our plan is to be expanding the plant database in each version release. All right. So if you have already the information for a new for a missing plant species, right now you need to do it manually, okay, and add it yourself. All right. So do you have any other questions? It doesn't need to be now. I mean, if you practice with the program, you work with it, you test it out, we'll be very happy to hear from any requests, okay, questions or things that you will be useful for your work. So well, I will be happy to hear from you.
Yes, I also recommend for everybody, just try it, download the trial version, try for a test project, try the features or the plan database, how it's working. Szóval mindenkinek javaslom, hogyha érdekli, töltsön le egy próbaverziót, próbálja ki saját maga is, hogy működnek ezek az eszközök. AutoCAD-re és Rhino-ra elérhető ez a program, és ki tudja próbálni egy hónapos próbaverzió keretében. Hogyha közben vannak kérdések, akkor hozzánk is tudnak fordulni, vagy közvetlenül Francesc meg tudja válaszolni őket. Ha esetleg hozzánk a HungaroCAD-hez címzik, mi közvetlenül továbbítjuk neki, vagy pedig őt is meg lehet találni a Lens Design-nak az elérhetőségein. So Francesc also can be found if you are searching the contact page on the Lens Design homepage, or you can write directly to us in HungaroCAD.
Exactly. You can find me or my colleagues here, and we'll be happy to hear from you. Also, if you want to have this material, I can share it with Zoltan, so he can forward it to you. And if you want to play with this Grasshopper definition or this 3D file, I can share it if you want. Okay.
Thank you, Francis. Köszönjük szépen mindenkinek a figyelmet és a kitartó részvételt. Hogyha felkeltette az érdeklődését valakinek a program, akkor állunk rendelkezésre a jövőben is. Köszönjük szépen a viszonthallásra, viszontlátásra. Thank you, Francesc.
Thank you.
Presentation.
Thank you so much. Bye.
Have a good day.
Goodbye.
Goodbye.
Bye.